Hello class, today we're going to talk about multi-step inequalities. But let's first review what we have to do with multi-step equations. So if you remember correctly, we had three basic steps to solve multi-step equations. Step number one, get your letters on one side. So in this particular problem, we're going to first change our subtraction to addition next to its opposite. Now I need to move my 9x to be with the 4x. So we do that by adding its opposite. So I add a negative 9x to both sides, and then we simplify that line. So 4x and negative 9x would give me negative 5x. The 8 slides on down. My equal slides. My 9x's cancel each other out, and I'm left with a negative 12 on the right-hand side. Now, step number one is accomplished. The letters are on the left. So now I need to get my numbers on the right. So I move the 8 over to be with a negative 12 by adding its opposite. We end up with negative 5x is equal to negative 20. Now, to solve, we just divide by negative 5, and we end up with x is equal to positive 4. So with equations, three basic steps. Letters on one side, numbers on the other, solve. The reason why we're doing all this is what the state of Texas tells me to teach. In 8.8a, it says we've got to write one variable equations and inequalities with variables on both sides that represent problems using rational numbers. Rational number for coefficients and constants. So in other words, what that means is when given a word problem, I've got to be able to convert that into an equation or an inequality. The second step is we've got to write a corresponding real-world problem when given a one variable equation or inequality with variables on both sides of the equal sign using rational numbers for coefficients and constants. So in other words, when I give you an equation or an inequality, you've got to be able to match it to a scenario. The other thing that you have to be able to do is model and solve. Now we can't model, or we don't model inequalities. We do that with equations. But we do still have to solve both. Okay, so let's dive off into solving multi-step inequalities. What you found out so far is that for inequalities, we solve everything exactly the same. There's only one minor step. When we're dealing with the equation, we get our letters on one side, get our numbers on the other side, and solve. With an inequality, we have to focus on this last step, because if our coefficient is negative, we know our inequality is going to flip. So that's the only real difference with equations and inequalities. So here's our first question. So the first thing I'm going to do in this one is I'm going to change my subtraction to addition next to its opposite. Now I have the setup like I want. Letter, number, letter, number. So now we start exactly the same way we started with an equation. We start by getting our letters on one side. For me, I like my letters on the left. So I'm going to subtract my x on the right. I'm going to subtract the x on the left. So my x's on the right go away, and on the right-hand side, I'm left with 2x plus 5 is greater than negative 8. Step number one is accomplished, exactly the same as the equation. Now I'm going to get my numbers on the other side, so I'm going to subtract 5 from both sides, and I end up with 2x, my 5's go away, is greater than, and negative 8 and negative 5 make negative 13. Sorry for the coughing. So now I need to solve. So this is where I've got to think. I've got to think about that coefficient. Now my coefficient here is positive, so nothing's going to happen to my inequality. If that 2 were negative, then I would have something to do. So now I'm going to divide by 2. I end up with x. Negative 13 divided by 2 gives me negative 6.5. Decimals are perfectly fine as long as they're not repeating. And because my coefficient was positive, my inequality stays the same. So every single step there was basically identical as what we do with an equation. We just have to think there at the end, am I going to flip or not flip? Let's try another one. Now in this particular problem, I'm actually going to work this one two different ways. Okay, so on this one, I'm going to see if I can move this real quick. And it won't let me move. I was going to move that over so I could solve it, do two different things. So in this particular problem, what I'm going to do is I'm going to solve it this way, then I'm going to turn around and I'm going to solve it another way. Okay, so and it'll kind of show you what happens when we deal with our inequalities. So the first thing we're going to do is we're going to change subtraction to addition next to its opposite. Then I'm going to move my 9x to be with the 13x. So if I do that, I'm going to subtract 9x. We'll subtract 9x, and I end up with 4x plus 8 is greater than or equal to negative 12. Now, if I were to write this one again real quick, I'm going to just write it over. I'm going to solve it down here below. So what if I move the x's to the other side? What if I move that 13x over to be with that 9x? Is that going to change anything? Well, if we do, because you can move that x to whatever side you want. Okay, so here my x's go away. I'm left with 8 is greater than or equal to negative 4x plus negative 12. And you'll notice those two are basically the same. Okay, so now I move this 8 over to be with a negative 12. So minus 8, we end up with 4x is greater than or equal to negative 20. This one we do the same thing. We'll move this negative 12 over to be with the 8. When I do that, I end up adding a positive 12, add a positive 12. I end up with 20. It's greater than or equal to negative 4x. So again, those are virtually identical. But if you'll notice up here on the left, on the top question, if I actually finish this one out, divide by 4, I end up with x is greater than or equal to negative 5. Nothing happens to my inequality because my coefficient is positive. But if I solve the one down below, where I've got a negative 4, I divide by that, I end up with negative 5. I end up with my x, but because my coefficient's negative, what's got to happen to my inequality? It has to flip, so it becomes less than or equal to. So negative 5 is less than or equal to x. So are those two inequalities the same? And yes, they are. Because you'll notice the mouth of the inequalities, open it up to the x, same thing on this side. So my point for doing this is the fact that depending upon which way you work in inequality, you may have to flip the inequality or you may not. All depends. And what determines that is that coefficient. If that coefficient is negative, you're going to flip the inequality. Now let's bump it up a notch. What if we have fractions? Will that cause any differences? No. You could change them to decimals if you want to. I choose to leave them as fractions. So we do everything exactly the same. We change our subtraction to addition. I'm going to move this 3/2 over. So I do that by doing a negative 3/2 m. Okay, we add, and 1/2 plus negative 3/2 will actually give you a negative 1m plus 3 is less than. These go away, and I'm left with a negative 12. So again, I move the 3 over. So minus 3, you end up with negative 1m is less than negative 15. But I don't want to know about negative 1m. I want to know about positive 1m. So I divide by negative 1. I end up with m. I end up with 15. But what happens because my coefficient is negative? My inequality flips. That's all there really is to it. Now, there are two other instances that we will need to focus on when we're dealing with inequalities. And that is, what happens if my letters they cancel each other out? So when you have a problem like this, we know that it's not quite what I'm looking for because I need letter, number. And this one's got letter, number on the left, but on the right-hand side, it's got some things that can go together. The 2x and the 3x would go together to make 5x, and then plus 9. So now it's where I want it. Now, back when we were dealing with equations, this should have sent up red flags because our letters on both sides are the same. Okay, so we know that because our process says that if our variables are eliminated, so the first thing I need to do is I need to eliminate my variables, and I know they're going to eliminate because they're the same, and I end up with 9 is greater than 9. Now, in equations, when both sides were equal, we knew that it was an all real numbers solution. But in this one, we got to determine whether or not that statement is true. Is 9 greater than 9? And it's not. So that means this one is a no solution problem. So you can still have your variables eliminate, but in an inequality, you've got to determine if that is a true statement or not. And you've got to think about greater than, less than, things of that nature. So let's look at one more real fast, and then we will call it a video. Okay, so in this one, we've got negative 4n minus 7 is less than or equal to negative 8 minus 4n. So again, you've got the 4n's that are the same on both sides, so that should kind of clue you in. Okay, so again, I change my signs and I get rid of my letters. So I move this 4n over. So positive 4n, positive 4n. My 4n's go away and I'm left with -7 is less than or equal to -8. And is that a true statement? Is -7 less than -8? No, it is not. Okay, so this one is still no solution. So to solve inequalities with variables on both sides, we know we do basically the same 3 steps that we do with equations. Get your letters on one side. We do that by adding the opposite. Get your numbers on the other side. Okay, we do that by adding the opposite. And last but not least, we solve. And this is where we've got to kind of focus on if that coefficient that's with our variable, that number that's with our variable, if it is a negative, you're going to flip the inequality. So that's all we got to do in order to solve multi-step inequalities. So until next time, I'll talk to you later.